So now, today I'm going to cover chapter 4, which is about processor and memory modules. You know that CPU, or central processing unit, is responsible for performing the calculations and doing arithmetic comparison. Okay, so it receives data and instructions and performs calculations, or logically compares the statements. That's the main duty of the processor. So it has to have information exchange with other parts on the computers, like memory unit, hard disk drive, and etc., and operating system. And then it performs the calculation and sends the result back to the hard disk drive, to the memory, and etc. Okay, so the main objectives for this chapters is to be able to compare characteristic and purpose of Intel and AMD processor used for personal computers, install and upgrade the processor, compare different kind of physical memory, and how to upgrade memory. In today's lecture, I'm just going to focus on central processing unit, and we will do memory like random access memory on Friday. All right. So the two main manufacturers of the central processing units are AMD and Intel. So processor is a hardware component installed on the motherboard, and it is the device that determines the processing capability and performance of the system. Okay. So the two major manufacturers are Intel and etc. So the main features of the processor that affect its performance include processor speed or processor frequency. Processor speed is the speed at which the processor receives information, performs calculation, and sends back the results. Okay, and it is measured in gigahertz. So let me in megahertz. Hertz is the measurement unit for analog signals. Let me show you how we can calculate transmission speed in hertz. Paint. Okay. So as you guys know, we have two types of signals. First, we have digital. We discussed these two types of signals in class. And analog. Digitals are discrete type of signals like 0 and 1. Okay. And analog is a kind of continuous signal. Continuous signal. The difference between digital and analog is that in digital we have limited number of values between each pair of numbers. Like this binary data, we have only 0 and 1. We can count this number. But for analog, suppose between 0 and 1, there is an unlimited number of real data between these two, each pair of numbers. Between 0 and 1, we have million or even billions of values, like 0.001, 0.00001, and etc. So these values are uncountable. So analog or continuous means continuous measurements over a certain period of values or numbers. In computer, everything must be converted into digital or analog, but there are some devices that receive information in analog and then convert them back into analog. So what do we mean by hertz? The CPU speed is measured in hertz. Hertz means symbol per second. per second. Okay, let me show you what I mean by symbol. Suppose we have these two axes. Okay, this is the time axis, and this is the magnitude of our signal, M. This is one symbol. Two symbols, three symbols, and four symbols. And suppose here is second one. Here we have four symbols, 1, 2, 3 complete symbols. We have 4 symbols per second. So now we can say in this kind of diagram, our transmission speed is 4 symbols per second. Okay, 4 symbols per second, or 4 hertz. So hertz is the measurement unit that calculates the number of symbols per second, and it is used for to measure the analog signals. For digital signals, we have bit per second. Suppose if our CPU or any kind of electronic devices can transmit 4 bits or 4 digits per second, our transmission speed is going to be 4 bits per second. But to measure the analog signal, the transmission speed of an analog signal, we use hertz. Hertz means number of symbols per second. Is there any question regarding these two types of signals and their measurement unit, and especially these hertz? Let's look at your comments. No. Okay. No question? All right. Let's move on. So our processor speed is measured in hertz. We have like 3.3 gigahertz CPUs, which are common for modern CPUs. And I think the maximum speed on current CPUs is something around 4 gigahertz. Giga means 4, means 10 to power 9. 4 gigahertz, 4 gigahertz, it means 4 times 10 to power 9. Giga means 10 to power 9. So which means this processor can processes 4 times 10 to power 9 symbols per second. That's the processing speed of that CPU. The next element is the socket chipset on the processor can use. The third characteristic of a CPU is the processor architecture. Just a moment. Mute. Okay. Processor architecture. We have two general architectures for CPUs. In terms of architecture, we have processors that can process 32 bits at a time, and we have processors that can process 64 bits per second. Okay, and based on these two architecture, we have two types of operating system. If you look at the operating system of your operating system, or like Windows and etc., it has to be either 32-bit or 64-bit. 32-bit, it only works with 32-bit operating systems and CPUs, and the same for 64-bit. And we have also hybrid architecture that can support both these two architectures, which means they can process 32-bit at a certain point in time, which means the length of the data or data unit that they can receive, process, and then send back is either 32-bit or 64-bit. So in terms of architecture, we have these two types, and we have multiprocessing abilities, which can be divided into these categories: multiprocessing, multithreading, multicore processing, and dual processor. We're going to discuss these four types of multiprocessing abilities a little further in the next slides. The other characteristic of a processor are features affecting processor performance, like memory cache security, memory features, support for virtualization, and integrated graphic. So now, types and characteristics of a processor. A single processor is expected to receive and handle one process at a point in time. In order to improve its performance capability, we can run or execute multiple instructions and etc. So to improve its performance capability, we can use one of these methods, multiprocessing. In multiprocessing, we need multiple processing unit, ALU, arithmetic unit, within a single processor, and each ALU can process one process at a single time. So ALU, let me show you with this diagram. Suppose this is a CPU. Do you guys have any questions? Let me see. What is more common, 32-bit or... Nowadays, 64-bit is more common because it can process information and instructions more quickly. No lie. Okay, so suppose here this one is our CPU. Inside the CPU, we need a unit called ALU. This ALU, this performs calculations, and also it executes and also compares, does the logical comparison. Arithmetic logic unit. The ALU can perform these two tasks. It can perform regular calculations, like 3.5 equals 8. It receives information, data like 3 and 5, as well as instructions like plus and equal. These are the operators, and then performs this calculation. This is one of the features of the ALU. The other feature of an ALU is to perform logical comparison. For example, if x is bigger than y, then z equals x plus y. Otherwise, z equals x minus y. This statement, this part is a kind of logical comparison. So it can, ALU has the capability to perform calculation and also to do logical comparison. So that's what an ALU does. Logical comparison and mathematical calculations. Okay. So in order to improve the capacity and also performance of a CPU, we can define multiple ALUs inside the CPU. So we can process multiple instructions at a time. So first, we can use multiprocessing by using multiple ALUs. Instead of just one ALU, we can define let me just copy and then paste. This current CPU can perform 2 instructions at a time. So we can, instead of giving just one instructions, we can give another instruction. 2 plus 4 equals 6. So it can concurrently process these 2 calculations by having 2 ALUs, arithmetic logic unit. Okay. The second method, this one is called multiprocessing, using multiple ALUs. The next method is called multithreading. What do we mean by a thread? Thread is a kind of process that operating system turns over to the CPU. Any questions so far? Is everybody with me? All right. So what do we mean by a thread? So ALU can receive instructions and perform calculations. So ALU only works with instructions. The second method is called multithreading. So first we have to define a thread. What do we mean by a thread? Thread is a task that CPU, that operating system hands over to the CPU. This is a thread, and each thread can contain multiple instructions. Each thread can contain multiple instructions. Okay. This is the next method that we can use to improve the performance of our processing performance using multi-threading. Each thread includes multiple instructions. Okay. So each processor and core processes multiple threads at the same time. Each thread can contain multiple instructions. The next method is multicore processing. In this method, multi-core processing, instead of having one CPU, we may have one CPU with multiple core. Multi-core processing. Okay. Suppose this one is a CPU, and instead of ALU, we have multiple cores. Core 2, Core 1, Core 3, uh, let's see, it's not moving here, and Core 4. Here in this picture, we have a quad-core CPU. Each core can process multiple threads. Each thread contains multiple instructions. So this way, we increase the performance of the CPU. This is called multi-core processing. Each core is a kind of logical processor inside one physical processor. In multi-core processing, we have one physical processor, but inside that physical processor, we have multiple logical processor called core. So we have single core, double core, triple, four, and also 8 cores. The maximum core that is currently used in CPUs is 8 cores. And the other method is to have dual processors. Instead of just one physical processor, uh, we can define multiple sockets on the motherboard and have multiple physical processors. Does that make sense? Okay, perfect. So in this picture on the left, we have a quad core processor. This one is a one physical processor. Within that physical processor, we have 4 cores, CPU. And each um, core or logical processor can handle 2 threads at a time. So this processor can handle 8 threads at a single time. This way, we raise the performance of our processor. And on the right, we have an Intel server board with 2 Xeon processor sockets. In this main board, we have 2 different physical processors. I hope that the difference between logical and physical processors is clear. Okay, so on the right side, we have 2 physical processors. On the left side, we have 1 physical processor, within which we have 4 logical processors called core. So whenever we say core, we mean logical processor inside the physical processor. But on the right, we have 2 different and separate physical processors. So inside a processor, we can define a kind of memory, which is the fastest type of memory inside the computer. This is called cache. Memory cache is the amount of memory included within processor package. We have 3 levels of cache. Memory on the processor die is called level 1 cache. Memory in the processor package, but not on the processor die, is called level 2 cache. and some processors use third cache, which is further from the processor, but it is still in the processor. So any kind of memory inside the processor unit is called cache, which is the fastest type of memory. It is also, we have also static RAM inside the memory. So let me look at your questions. Let me finish this part and then I will answer your questions. So memory used in a memory cache is called a static memory because it does not need refreshing. But memory used on the motherboard but not inside the memory is called DRAM. So this DRAM can lose data quickly, so it needs refreshing. So because of this refreshment, its speed is lower than static RAM. Static RAM can hold information for a long time. So now let's go to your questions. So the left picture only had one CPU even though it had 4 boxes within the box CPU. Yes. Let's go to this one, okay? On the left side, this is one physical CPU. Inside that CPU, we have 4 cores, okay? This CPU means core, 1, 2, 3, 4, okay? So this processor can do multi-threading with multiple cores. One physical CPU with multiple logical cores. But on the right side, we have 2 separate CPUs. One here and the next one here. We have 2 different physical CPUs. And within those physical CPU central processing unit, we can define multiple cores, at most 8 cores inside each each physical CPU. JC, does that answer your question? The bigger box was the physical CPU chip, and the smaller blue one were the logical processor inside of it. Okay? Yes. The left side, one physical CPU with 4 cores. Right side shows 2 separate CPUs, 2 separate physical CPUs. What is the purpose of threading? All right. So CPUs can perform and execute one process or one instruction at a time. To improve its capacity and to be able to process multiple instructions at a certain point in time, we can use these methods. Thread includes multiple instructions, and we assign each thread to one logical core. This way we can process and execute multiple processes or multiple threads at a single time. Let me elaborate on that a little more, okay? We have instructions, okay? CPU performs or executes one instruction at a single time, okay? What do we mean by instructions? Something like this. 3 plus 5 equals 8. This is called an instructions. But we want to raise the performance or the speed of our CPU. One way is to put instructions and process multiple instructions at a time. We can define threads. It includes multiple instructions, which means each thread can have something like this. 3.5 equals 8, 2 plus 2 equals 4, and etc. Multiple instructions within a thread. Okay? So in order to execute a thread, we need a single core. Each core can process one thread at a time. And each CPU can have multiple cores, and each core can execute one thread at a time, one or multiple thread at a time. Is that clear right now? Okay, let's go to, I was just confused by each little box and the word CPU in it. Yes, just take those CPUs on the left side. These are cores, not CPU. Sorry about that. This is a quad core processor. We have four cores or four logical CPUs. So in an 8-core processor, can it still only handle 2 threads per core? No. In 8-core processor, instead of having 4 cores, we have 8 cores, like this. Here we have 4 cores. In 8-core processor, uh, let me show you here. Core 8. This is an 8-core processor, and each core can handle or process multiple threads. It's not limited to just 2 threads. It can handle 4, 5, and etc. It depends on the structure and architecture of the CPU and its internal structure. It can handle multiple threads. So I want you to distinguish the definition and the difference between core, which is a logical processor, and a physical CPU. Each core can execute multiple threads, and each thread contains multiple instructions. And each core can handle multiple threads. It's not limited to just 2. Let's see if you have any other question. I know, but in a quad core, each has 2 threads per core. Yes, in this picture, yes. We assume that each core can handle 2 threads. But we may have cores that can handle multiple threads, 4 threads, 8 threads. But for this picture, yes. Okay, thank you. What's the maximum amount of thread one core can handle? It depends on the architecture. There is no maximum limit, and the processors are evolving every day. You have to look at the user guide of the CPUs to see how many threads they can handle. And you can also check that if you go to the BIOS of your system. When you restart your system, press the delete button, and then you will go to the BIOS of your system. There is a menu for CPU, and it defines how many cores are there in your CPU and how many threads your CPU can process. Yeah, my CPU can handle about 500 per core. Yeah. That depends on the architecture and also the speed of your CPU. You can check it in your BIOS system.